Good afternoon and welcome today to InvestorCube's latest webinar featuring Aduro Clean Technologies, a Canadian-based company traded in Canada on the CSE under ticker symbol ACT, in the US in the OTC markets under ACTHF, and on the FTSE under D950. I'd like to start off the webinar by introducing Neil Simon, CEO and Chairman of InvestorCube. Neil founded InvestorCube in 2004 after a successful career in financial services as a financial advisor, consultant, and distributor of financial products. His extensive background in the industry relationships are the cornerstone to InvestorCube's business model. His passion for representing clients and their interests drives InvestorCube's company culture. I will now pass things over to Neil.
Thank you very much, Dennis. Good afternoon, everybody, and welcome to the InvestorCube webinar featuring Aduro Clean Technologies. Clean tech sector, as everybody knows, is a sector of interest to almost all leading asset managers, institutions, advisors, and investors alike. Aduro represents what we believe a great opportunity to invest and participate in a growth-oriented company that is on their path now to commercialization with the onset of revenue and earnings growth. Ofer, the CEO, will go through his presentation today talking about the patented technology Aduro has developed over the last many years, where this company is going over the next 1 to 10 years, and why we believe at the current market cap and current price, this is a stock that should be looked at and more importantly should be purchased. On that note, I will hand it back to you, Dennis, who can introduce Ofer, who will go through the presentation, which will follow with a Q&A session after the presentation. Thank you again for attending today's webinar. We look forward to talking to everybody in the future. Look forward to more webinars, and I'll hand it back to you now, Dennis. Thank you.
Thank you, Neil. Before we get started, a little bit of housekeeping. Please take a moment to review the disclaimer, which is on the screen. Thank you. For those on the call today, there will be a Q&A after the presentation. In the meantime, you can post your questions in the chat. I will try to get to everyone's question as time permits. In case you would like to review the webinar after, we will be posting it to InvestorCube's YouTube channel for you to review again. Now, I would like to introduce Ofer Vicus, the founder and CEO of Aduro Clean Technologies. Ofer Vicus has over 15 years experience in developing and marketing innovative technologies and processes in Canada and abroad. He has a passion behind Aduro and it's responsible for building its research and business team. He has extensive knowledge in alternative approaches for petrochemical process with a focus of limiting environmental impacts of the traditional chemical and petrochemical industries. He has distinguished himself through his ability to bring ideas to reality with advanced academic research, strong intellectual property foundations, and support by governmental programs and industry partners. Mr. Vicus previously held leadership positions with Spectronics Limited, Qualion NMR, and Cura Pipe Systems. Mr. Vicus holds a Bachelor's of Engineering in Industrial Engineering by Sutherland University School of Engineering and Advanced Technologies, and Executive MBA from Northwestern Kellogg Tel Aviv Rekanati University. Now, I will turn it over to Ofer to tell you a little bit more about Aduro Technologies.
Hello, guys, and thank you for having us. Thank you for the InvestorCube team. Thank you for Neil and Stella and Dennis for the work that they've been doing. My name is Ofer Vicus. I'm the CEO of Aduro Clean Technologies, and I'm joined here today with our VP Business Development, Abe Dyke. Want to say hello?
Good afternoon, everyone. Thank you for joining us.
We planned this presentation to show you our commercial path. The way we plan the presentation is that we put, a little bit of 50% of it maybe is about our technology, talks about our technology and about a little bit of the background and how did we reach that day. But then we're spending the other half of the presentation on our commercial path. Would like you to see what we achieved so far on one hand, but we also like you to get excited like we are from our, the opportunities that we are having and our avenue through that opportunities. With that, I'll start. I anticipate that there is a bit of some new shareholders there. So for that reason, a little bit of a background of who we are. We started in 2009 and we've incorporated in 2011. We developed a platform, a chemical platform-based technology. Basically, it has a lot of capabilities in different sectors. Over the years, we stayed under the radar, and recently, in April 2011, we become public. We have an operation in Southwest Ontario where we have an R&D center, a lab. We initiated our work at the University of Western Ontario, but moved recently out of there, and today we are working to open our new pilot site again near Sarnia in Western Ontario. In this presentation, I'd like you to take at least three major items that I'd like you to consider. First is our path forward from commercialization. So in this year and the next year, we will work very hard to put a pilot in place. Second is our engagement with different customers. Even now that we don't have a pilot, we have gained a decent amount of customer interest, and we'd like you to see that as well. And we're expanding on our lab, basically, to be able to cater to those customers' demand. We're after third-party independent validation of the technology. That means that from us, that the technology, the science is there. It's very solid. We've done thousands of experiments in the lab to prove that. It's time for us to build pilots and prove the economic model that we've been envisioned. The technology is protected with 7 patents, and there is extensive patent strategy that goes all the way to 2011 as we initiate the first patent. But we are extensively busy with R&D, with research, and we see more patents coming forward. We have a strong global interest in different countries. To this day, from April till today, I think there are 13 possible engagements, and this is, before that we had no social signature. So that speaks a little bit to the potential and the opportunity that the technology represent. We are an experienced management team, very loyal. Most of us have been staying in the company for the last 7-8 years. We just add a COO, a very experienced COO that came from Siemens to join us, and we are growing on the technical side. We're putting about multiplying our team. Probably in this year, we'll gain another 2 or 3 people on the technical side. And as it seems, we will be growing also internationally, so establishing some offices probably in the coming future. What we see is the Netherlands as being the right place to establish ourselves. 5 people on our board of directors, out of which 2 are independent. Aduro has 3 verticals that we are working on right now, and 2 that we are not talking about at all. I'll start with the 2 that we're not talking about. These are recycling of waste tires and rubbers, and the other one is recycling of lubricant and waste engine oils and such. I mean, whatever Aduro is doing right now is pretty large in scale, and there is enough for us to achieve currently. We started our journey with the bitumen, upgrading of bitumen, basically changing the properties of chemical and physical properties of bitumen, improving its value. And we did it, we initiated in 2011. Through our process, we moved into investigating of renewable energy and transforming renewable oils into renewable fuels and specialty chemicals. And recently, we have developed our plastic upscaling philosophy, where, in a way, and just to make you the connection, we didn't think we will do all of this at once. It's embedded in the DNA of the technology. So a lot of what we're doing in the bitumen is connected to the plastic, is connected as well to the renewable. And just to give you an idea, we call asphaltene, which we are changing and upgrading, nature's polymer. That's what we're doing in the lab. Scientists may say no about it. To us, it's very similar to the behavior of plastics in the reactor, basically. Over the years, we've been survived by government grants. We did a lot of work over the last 10 years with government grants, and we're definitely looking to expand this work, both internally in Canada and probably outside. We have done a lot of work with the academia. We spend most of our time at the University of Western Ontario before we opened the lab. And we see definitely expansion right now that will go forward into Europe, probably with engaging with research institute that really interested in what we've been doing. There'll be press release associated with that in due time. We've been working recently as we are moving from the lab to a commercial space. We've been working with an engineering company. This one is XSG from Alberta, but we already see engagement that is possible engagement in the Netherlands. Again, that associate more on the plastic side, but will expand our capabilities in terms of the engineering side. Over the years, we've done several commercial engagements. Some of them we cannot disclose. We're in active engagement with a major oil company in Alberta, but it's under NDA and we cannot disclose it. We engaged Greenfield Global at some point of time during 2015, 2016, and investigate basically the work on renewable. And recently, and the most major advanced operation that we did is our public engagement with Switch Energy. This is an agricultural waste collector company that's been spending the last 20 years looking for solutions to agricultural waste. We liked it a lot because of the unified product or feedstock that they're producing on one hand, and the difficulties in terms of contamination on the other hand, things that we thought we could capture, and great placeholder to represent our technology and the capability of our technologies. While Switch Energy is doing, we're doing this work with Switch Energies on the single stream product that is called the polyethylene. In that sense, to prove the technologies, in recent years, we engaged Brightland. At the beginning, it was a little bit more of confidential. Brightland has taken their time Brightland Camelot from the Netherlands has taken the time to observe the technology, to look for its performance, and basically develop an opinion about it. For the new investors that haven't seen or heard before, Brightland is Europe #1 or one of those largest chemical hubs in Europe. They provide 40% of all chemicals in Europe. They are an association with about 120 companies, big and large, surrounded by academia, research institute, laboratory, and pilot size. They really like what they see in terms of the technology behavior and its technology potential. And with that said, we spend the time for Brightlands to look at what we've been doing and develop an opinion about how to move forward. Basically, if we're doing polyethylene, a single stream product with Switch Energy, Brightland really looking forward for us to develop a solution for plastic that is otherwise harder to process. The technology itself has unique capabilities to observe and process different types of feedstocks, and that enable different types of solutions that Brightland likes a lot, because currently most of the technologies are rejecting this type of feedstock, and the commercial opportunities there are huge. So, if we are looking at the process, for the investors of you that listen, if polyethylene, a ton of polyethylene worth about $200 in Canada, and we can process it to something worth about $1,000 worth of good. In Europe, the same ton of polyethylene will worth about $650 Canadian dollars, and we'll have to produce the same type of commodity product that worth $1,000. So the gap is quite wide. But on the other hand, feedstock that is otherwise, would be rejected. Our team was just yesterday is coming back from a serious meeting in Brightland, and one of the garbage collectors testified that they have for some feedstock that we can process has a negative cost of 60 euros. So about 100 negative cost of about $100, from which we can move on and do a commodity that's worth 1,000 tons. So that's exactly what Brightland see in us. In the last 8-9 months of our operation, we also gained an impressive list of I'll say possible engagement. We, Kate, we left them in general confidential. Some of them are, large size organization, and some of them are small size organization. I think we will, as we move forward, and we will materialize on those agreements. We will publish them. The way we see our business model is to the investors that knows how we are, operating because of the flexibility that technology is doing. We like to provide in a solution to businesses first, and we select our solutions based on the sectors. For example, food packaging or agricultural waste. Sectors that otherwise will dump their waste into the landfill stream and will has currently a different solution, different ways to process it. But on the other hand, possible solutions that we can avoid from dumping it into the plastic, into the landfill waste or landfill stream, and just turn it into some kind of a good value, higher value product already on site. And I'll just say that under this concept, we have several small scale businesses, this confidential list, but we also have some of the Fortune 500 companies that are associated with the, general recycling in general. With this, we'll move forward. I'm very excited to talk to you today about the technology. What is the technology that we've been developed? Again, for the new guys that are, haven't heard us before, this is a chemical conversion platform. It's activated by a catalyst and a chemical agent. It's operated in low energy mode, and its yield is very, very high. We're getting, in general, just based on the recent lab work that we've been doing recently, about 90% yield. We recorded 90% yield while operating on temperatures, average temperatures that are below 400 degrees. This is a quite unique in our industry. Most of the technologies are crossing that type of temperature regime. The chemical or the catalyst that we're using is somewhat of a low value metals. Some of them are available in the bitumens, and otherwise you can buy them in the regular market. They have a low, some kind of a price value, but they're definitely not anything noble or that costs a lot of money. And the chemical agents for us is some material that is derived from bio-based, if you will. So things like ethanol, glycerol, cellulose. The nice part, for example, in our plastic operation is that we're taking this chemical agent actually from the feedstock. So just to give you an idea, if you want to process mixture of plastics, and we will need some organic hydrogen contribution, we will take it from the plastic bottles that are available in the stream, and we'll just add some more plastic bottles. On the other hand, just to speak about the configuration and the power of these technologies to answer the different scenarios, if we are operating on renewable oil, we'll then add some metals into it, but really we'll take the glycerol and turn the glycerol into some kind of an organic hydrogen. The same goes with the bitumen application, where in the bitumen section, we will simply increase the metals without discriminate. Whatever the metals are there, we'll just increase the concentration of the metals in our stream, and we will introduce some hydrogen, organic hydrogen donor into this stream. Overall, it speaks to the technology capability to do a few things. First of all, to configure itself, based on a territory that it's been there. And second, to provide solution locally, because it doesn't need a lot of resources. Remember, it's working on a small and a lower temperature regime, basically, with a higher yield. So that speaks again to the possible technology, maybe to answer into a different type of business scenarios, basically. Of course, it has significant environment benefit, not just that we can cater a solution for, in a small scale, but we're also saving the benefit, the negative costs that are associated with maybe transferring some feedstock or waste one way or to the other. And that is, when you consider life cycle assessment of a technology, that becomes really significant. So just another adding value. I'll say that from this point forward, we will focus our presentation on on polymers. Basically, in our business program, we integrate two scenarios. One of them, the major one, will be the plastic, and the second one will be the heavy oil, basically. But going forward from this point, we will discuss simply polymers, because I think it's an easier example of how to present the power of this technology on one hand. On the other hand, the market is very hot. We're in the right place in the right time, and we feel we can commercialize on some of those opportunities immediately while we are moving forward in our commercial path in stages, I'll say. Some of the benefits that if I talked a little bit about the technologies, what the technology is capable of, then embedded in these capabilities are the advantage that the technology represent. All of it, what does it mean? It means basically that we can think of different business models, different type of operations, sometimes smaller, sometimes with the lower entry point to a market, while we're producing the same commodity product that otherwise would be sold in the market. So, the technology is very, has a high level of fixed feedstock flexibility, not just in its sectors, being able to capture and operate on bitumen or on asphalt, different type of product. For example, in the renewable, we can accept almost any type of renewable oil into it, and same process, basically, believe it or not. And in the plastic regime, we can operate on different types of streams, so pure material, or say polyethylene or polystyrene or polypropylene, or a mixture of material. And so that speaks to the high flexibility that the technology represent, because we're doing it in a low temperature, and because we're taking a lot of our needs from the feedstock. It's basically we can start in a lower scale mode, and we can ramp up our operation. So we don't need $100 million to centralize a location. We can start with $30 million or $20 million and ramp up that. And that gives businesses that otherwise had no solutions the ability, the potential of earning some money while working with us, learning of the technology potential and thinking of the future. And this is how we build our business model around that. So that speaks a little bit to the financial elasticity. In terms of efficient, just to give you an idea of what we're talking, some recent lab discussion work that we've been doing on polyethylene, and I'll present you some of those numbers. We see very high efficiency that sometimes, close to 90% in yield, which means eventually that most of the material that we are processing has some kind of a different value than it started with. So very, very important. Because of that, nothing left on the byproduct, very little byproduct, 4% basically on the current statement that I will show you. But overall, you can see the direction and where this technology can move on. I mean, the possibilities are there for us to capture opportunities that have not been available before. I talked before about the emissions, and I'll just repeat and says that not just that we're having lower emission, I'll give you some examples, but we're also saving a lot of the negative impact associated with those activities, associated with those, transporting material from A to B and sorting it and processing it. A lot of those are going away. A lot of those costs are going away with our process, basically. In these slides, we just want to show you how we see the world, basically, and where we stand, in light of other technologies that are in the business of processing feedstock, waste plastic feedstock. From left to right, we account really three major operation or approaches towards converting waste into some kind of a valuable good. The first one is thermolysis. This is where you inject high energy, one way or the other, heat basically, in order to break what we call bond rupturing of the moleculars, basically plastic, in order to change plastics from the status where they are into some kind of an oil or something that is worth a little bit more. You have to shorten the molecules, and injecting heat into this is basically breaking down the molecules. But if you do that, you have to deal with other issues such as extensive pre or post treatment. So under this heat injection, you can see companies like Agilis, Mura, Plastic Energy, Quantafuel, which is BASF, really technologies that are available one way or the other, either pyrolysis or hydrothermal liquefaction, that are dealing in different approaches on the same concept. So Sovolysis is another concept where, it's easy to give the example of just some kind of a car manufacturer with really a waste plastic unified type of waste material, waste plastic, where maybe the waste responds very well to some kind of a solvent, and so basically they mix it with that type of solvent, they regenerate it, they extract it back, and they can reuse it again. So it's about more of a niche solution. Solvation is the mechanical approach of basically getting rid of anything physical, contamination, impurities, sand, dirt, dye, all kind of issues that are related to that, where you are you're regenerating. At the end of the day, this mechanical separation cause to regenerate the plastic and to improve its value to a certain level. And you can do that with limited amount of time. Again, we approach it more of a niche because those solutions has to sit on a large assets, and they normally responds to single type of feedstock. The chemolysis, on the other hand, is as I mentioned, is a chemical breakdown or chemical conversion of those waste plastic, and it's operated, as I mentioned, with a catalyst and a chemical agent. But one thing to look at it is that chemolysis, for example, can do not just a single type of plastic, but maybe different types of polymers, either pure or mixed. So just to give you an example, by way of example, there's a company named PureCycle. They are operating on polypropylene. It's a Procter & Gamble operation. And they need, I'll say, some kind of a large, vast amount of product to sit on, and so there'll be a nice separation process at the beginning. The Aduro clean technologies, chemolysis technology, could operate both on the polypropylene, polystyrene, polyethylene in general. So we're just proud to say that we are the only company right now in this section that is operating, commercially operating on provide solution. But I should say also that it gives us a lot of flexibility as we are moving forward. That's it for the guys for the background. In the last few minutes, I thank you for listening to us. We gave you some background about who we are, what we're doing, how the technology operate, and what's the benefit that are embedded in it. In this coming slides, we translated to a commercial path where we will establish pilot, and we'll move forward with a 5-year plan that we are eager to share with you and show you why it's really the right time to invest in the company at this point of time. What I'm showing you in this slide is a simple case study that we've been doing on polyethylene. This is just some lab results that you can see, but on the left, when we're processing pure single stream of plastic, in this case polyethylene, we came up with 90% liquid yield that's worth quite a lot, and we can sell it. So in other words, it starts maybe in a certain value, maybe $200 in one case per ton. In Europe, it's about $650 per ton, and in Mexico, for example, it's worth less. Okay, but 90% of it can come up and produce into transform into a product that's worth closer to $1,000 per ton with a liquid yield of 90%. Then we produce about 6% of gas and 4% of byproduct. Of the 6% of gas, I should say that 60% of them are just the gases that we can use to regenerate the system, which speaks a lot to the level of energy we require. The system is required on one hand, and so we need to compensate and add some energy, but it's really efficient. As you can see, it's very, very efficient process. On the other hand, 40% of those 6% are just CO2. Okay, so we have about 2.4% of the total mass that is coming out as a CO2, but really this is a very low number in comparison to anything out there currently. Keep in mind that we can do the same. We will not have the same result, but we will have higher result. We anticipate success, quite impressive success, where we will operate on the other type of polymers, such as polystyrene or polypropylene, or even mixture of those. The whole idea is to take this liquid yield and turn it into something that you can later do something with it. So in our case, we are thinking circularity, and so this oil that we're producing will move into a process to create new plastics, but it can also produce fuel, for example, and so we can answer to different needs in different territories, basically. Just to keep on why this is so attractive to the world, or to customers in terms of the circularity mode. So this is just a kind of a layout of what happened with the PE, polyethylene, in this example. And so there is a process there that takes ethylene and create plastic, PE plastic out of it, polyethylene, and then you move that into some kind of a product, and those products end up in the post-consumer, I'll say in the shops. You buy those things and then you drop them down and they end up in the waste, and we come down and collect them, or just process them. When we process them, we break the component back to an oil that could be used again to create polyethylene. So it's full circularity mode in our case. And bear in mind, we can do that again, as I mentioned, to other types of mixture of plastic, such as polypropylene or polystyrene. We're just now going to do some work on PVC, and so our goal is to increase our capabilities. But it gives you a sense, if we have a process out there that can operate in such level, in small scale, at low energy, and prevent a lot of the material to enter the waste stream, what does it mean? Well, it means that, for example, in terms of the customers, we can approach a customer that otherwise would dump this whole thing into the landfill or into some kind of a plastic or conversion or a collector. For such customer, this will be a cost center. And as the case with one of our possible engagement, we are offering a customer with a complex feedstock, such as food packaging, a concept where we turn a cost center into a profit center, where the customer could return that type of material back to his supplier and gain credit for it, just to give you an idea. So, if this is a sector related, say food packaging, we can multiply it across, that solution across food packaging. If we're working in the same sector on agricultural, we can work there and multiply our operation in agricultural. That means basically that, we are preventing for that type of waste to move into the land stream, and we keep it really without transportation at the same place, turning it from, I'll say, cost center to a profit center. As we move forward, we develop our concept of commercial concept. So what do we see basically? We talked about the technology as being able to be scalable in a small scale and being able to scale up. So basically, we envision small units with really good return, and in the next few years, we will develop a process that will be able to capture quite wide range of mixture of plastics, but it will start with a small unit, only 25 tons per day. And the idea is that if you have projects later that are bigger than that, you can just expand it. You can, we call it train reactors, and we just add based on the project, just more trains into it. So, what you see in this scenario are two cases, one of 20 tons per day with the performance that it has, but also a case of maybe 9 reactors, 200 tons per day. And so the vision is basically to after 3 or so years, just before that, between the 2 and the 3 years, to start fund the growth of the company and do work on projects rather than on the technology. So our plan is to commission 25 tons per day reactor and expand our processing capacity by adding additional reactor train. As I mentioned, this slide represents 8.5 tons per year of a commercial unit, and you can see what's the gain if we're doing it, what's the gross margin. We also give you an example of 200 tons per day, but I like to say that this is not the limits. I mean, we will approach different opportunities that has anything from 20 tons to 300, 400 tons. And all you have to do is, think of it, you start with a lower cost scenario, maybe with 1 or 2 train reactors. You like what you see, you understand the market, and you move on and you increase your capacity. So every customer that we have basically has the opportunity to grow because the customer understands best how to capture the waste around it, but also through our marketing program to provide the demonstrations, we will engage new customers. And going forward through the years, you'll see that there is quite a lot of opportunity to extend our commercial project. At the high level, you can see that there is a gross margin that is improving by about 12% in the plant. And that is mainly a factor of the economics of the scale and the manpower that required to run the equipment. Just to give you an idea, this use case illustrates a very healthy gross margin, close to 50%, and a payback of around 6 years. It is important to know that in this calculation, we have been using 80% yield versus the 90%, for example, yield that we mentioned before. We're taking measures to act conservatively, and going forward, as the performance will present itself, we'll improve those numbers. Anticipation is that we will improve those numbers. So what you see here, basically, this slide represents really a comparison between a licensing and an own-operate model. Here you can see that the own-operate routes deliver slightly lower gross margin with a significantly higher total gross margin dollars. Basically, we have to, on the own-operate, we have to pay for the feedstock. On the licensing, we don't. That's quite natural and understandable. But the dollar gain is a threefold, right? And what we gave you here is the same case scenarios, and just an opportunity to see how we see things between the licensing and own-operate. What I do like you to take from this, although we spend a lot of time to talk about licensing, I think our approach is to provide solution to customers. And so with that in mind, we will work with the customers. Some customers would want us to build on operate, and we will look into doing that. And some customers will just want to own some kind of a rights and move forward. And we will, of course, negotiate those as well. Slide 15, this is our path to commercialization. Since we've been going public in April, we've been delivered to everything we said on the, and plan basically at 2021, during 2021. The major item was for investor for us to demonstrate that the technology has some kind of a third-party validation. We did that, and we are going, marching forward towards building a pilot during 2022. We've been very busy over the last 6 months developing our relations with the different possible collaborators and customers. Among them, I talked about Brightland and Switch Energy, and this list is growing as we speak. Our team has just come back from yesterday from travel in the Brightland, and I can tell you that the list of engagement is expanding. We have ongoing discussion with over 13 entities across 7 countries, some of which are global players. As we, again, for the investors that listen, the new investors, we always talk about our possibilities to provide solution to large scale players and to small scale players. And in this list, we have a mixture, a nice mixture, a blend of both. And it's been growing as discussed. The next step for us is to engage these customers in customers trial to also materialize upon those engagement. This is part of the significant milestones we want to achieve during 2022. Complete our pre-pilot unit, commission the semi-commercial unit in over the next 12 to 18 months, and move forward in a commercial scale. If once we have the pilot, and if you consider maybe Ontario as a hub that is doing demonstration, and in less than a year maybe brought maybe 10 to 15 possible engagement, our ideas fast forward in 2 years time is to multiply this hub and develop different hubs in each territory. And so again, we anticipate that in each territory we will have a similar size of commercial engagement from which we can materialize towards actual projects. So this slide takes a global 5 years outlook at our plan and strategy. As mentioned, in the short term, we will commence to build out our first pilot and initiate our customer trials program. In year 3, we plan to have our first commercial unit operation, followed by ramp up of a global expansion through the establishment of a territory hub. Those hubs, as I mentioned, we anticipate that in each geographic area we'll have some kind of a representation that will be handling projects. For each hub, at this point of time, we have a local team of about 5. We accounted local team of about 5 people operating out in the lab and engaging customers in their respective regions, with oversight and guidance by our Canadian team. This will allow us to expand our reach and to take advantage of the increasing demand globally. So we like to answer, as I mentioned, globally, but locally to a customer. And we think this is the best, right now, the best approach to do it. This slide represents our PROFORMA financial forecast. While the numbers are modest in the upcoming 2 fiscal years, we'll be executing some significant operational milestones, such as the pilot, with ramping up our customer trial program and commissioning our initial first pilot. In the short term, the company will mainly be generating revenue from paid customer trials, but again, those trials every year we think we have a new flow of deals, potential deals from which we can convert them. Moving to year 3, we expect these numbers to become more significant with our trial commercial unit getting commissioned, at which point the company is expected to hit a break-even point. Things starts to get really exciting as we expand our commercial units and ramp up our processing. The level of growth can be seen in these 2 years, in the next 2 years, and can be expected to continue beyond year 5. In year 5, we plan to hit and even surpass a $95 million mark in recurring revenue with a very healthy EBITDA. Things starts to get exciting as we expand our commercial unit and ramp up our processing. The level of growth seen in these 2 years can be expected to continue beyond year 5. In year 5, we plan to hit and even surpass a $95 million mark in recurring revenue with a very healthy EBITDA margin as outlined in this graph. Guys, this slide I like this slide very much because it represents, it's one of the first slides we put at the beginning of when we started the journey as a public company. We stated there our expectations that we have a processing unit worth anywhere between $10 to $50 million, and now we're backing it up with some information that is based on lab and engineering. And in terms of the market size, we consider those numbers to be very modest. Really, the potential for the company is quite larger than that in every sector we are operating in. This slide is just to go back and give you some refresh on our share structure. Currently, we are, as you can see, a very tight share structure with about 48.9 million shares out there, inside ownership of 48%, some warrants and options in the making, and some special warrants that are out there for the insider, for the management. Basically, at the beginning of our journey, we put 66% of our ownership on the shelf, and we condition the receiving the return of those shares upon success. So the first time we perform the third-party validation, we brought about 33% of those shares back home, and we anticipate that in the next year will materialize based on the expected commercial engagement that we have, that we will materialize on those special warrants as well. The current market capitalization is also can be seen here. Thank you very much for having us, and we spend the time show you what is that technology, what's its capabilities, where we are, and I hope you get from this that we really think of the technology as a high growth investment opportunity, basically embedded in the technology benefits or the technology capabilities are a lot of benefits that cater to our market, that enable us to materialize on. So it's very modular and scalable. I spent some time to explain why the environment side is important and how we cater to emission reduction. It's very flexible in terms of feedstock, and it's diverse. Our capabilities can handle different types of feedstock in the single stream, multiple stream, mixture of streams. It's very cheap in comparison to anything others. Basically, it's operating in a low energy mode, as been discussed, and I can refer you to some presentation that we did recently in different conferences where our technical team speaks about why is it that we can operate in a low energy mode. Actually, quite fascinating presentations. If we're operating in a low energy mode and low capital cost, but we have very high yield, so of course it's we have high efficiencies. I mean, we spend the time to explain and show you a case study of 90% yield. This is really unheard in this industry, and through our business model, we were even more conservative and considered 80% of this yield, just to be on the safe side. It has very little byproduct, and so we think those opportunities give the company a lot of potential to materialize on projects. So I hope in our presentation, with that, I'd just like to take you to the last slide and why really invest with us now? What's the opportunity right now? As I mentioned, this is a unique patent technology that has been independently validated. We're looking at an output really bigger than an 80% yield for our operation and the feedstock that we will operating with, really a nice margin, nearing 50%. We have key engagements for our pilots, both in Ontario and in the Netherlands, and they are different. One of them is dealing with a single type of plastic. The other one is a mixture of plastics. We have an ongoing discussion that we gained in the last 9 months with potential customers across 7 countries, and we envision that if we'll build those hubs in the future, we will have the same deal flow in each territory, so multiple customers. We look at the ramp up of revenue occurring, annual revenue occurring, bigger than $90 million, with a nice healthy margin of 80% by year 5. And also as a management, as I mentioned before, management is fully engaged and aligned with the shareholder goals to increase value with 50% ownership, and eager to and hungry to present itself and demonstrate its capabilities. I believe that we are, seriously undervalued compared with our peers. Most of our peers are, to this day, are north to the $1 billion in valuation. We are, we have a long way to go from our 35 current market cap. With that, I'd like to say thank you very much for your time again, and we will now open the discussion for a Q&A.
Thank you, Ofer. And now, I guess at this point, we're going to turn it over to our Q&A portion of the webinar. I sent a request out to anybody. If you haven't seen it already, please type in any questions that you'd like answered by Ofer and his team into the Q&A chat part. We've also received a few and been emailed a couple of Q&A questions. So, Ofer, I'll start with the first one. How is your EBITDA margin so high in year 5?
Dennis, thank you. Maybe Abe, maybe you want to answer.
Sure. As we've been modeling different opportunities and projections on what we will be able to build. So in year 5, we're forecasting 1 commercial unit, which will be owned by the company, owned and operated, and with remaining projects under license model. And so essentially, those would have 100% margin on them. So this, of course, can change with different opportunities that come along.
Okay. Thank you, Abe. Next question we have here is, with the recent dramatic rise in the price of oil and natural gas, is there an increased urgency from your perspective, customers to fast forward your development?
Thank you, Dennis. So the short answer is yes, but of course, we wanted to think of this market on the long term, 20, 40 years ahead. And so only 2 years ago, we saw different scenario. We will absolutely increase our presence in terms of marketing and call out to customers to see us, and definitely accelerate our work, our current work in the lab to demonstrate the capability.
Excellent. Thanks, Ofer. I'm just going through the questions here. Ofer, here's another question we just sent in. How many projects are commissioned by the end of year 5?
Maybe Abe, you want to answer that?
Sure. Again, it goes back to the model, and by the end of year 5, we expect 12 projects up and running and under license, with one of them being a commercial project that we own and operate. That being said, our financial projections would increase significantly if we shifted some of these projects from licensed to own and operate projects.
Excellent. Thank you. And I see another one here. When do we expect to have Aduro's renewable vertical in action?
28 months. In 18 months, less than 18 months.
One last question here I see here. Debt financing for customers or for company build out. What does that look like?
Abe?
Sure. Post piloting stage, we believe projects can be financed at a rate of 65 to 85% of CapEx through various different types of debt options. And this is assuming a 4 to 5 times multiple on the free recurring cash flow.
Excellent. Okay, well, I don't see any more questions. I just want one last round for anyone who has any questions. Going once. All right, listen, I want to thank everybody. I want to thank Ofer and his team here today for Aduro Clean Technologies, and everyone who attended for listening today to the webinar. We will be posting the webinar on Investor Cube's YouTube channel shortly. So if you have any questions or want to review the presentation again, please feel free to see it. And I just want to thank everyone again for attending today. And we hope to see you again soon on our next webinar. All right. Take care, guys, and have a great day.